All right, welcome algebra students to our very first day of chapter 11, and there's a lot of weird stuff going on with chapter 11. We're going to bring in different types of radicals and square roots, and we're going to talk about what that is today, and it kind of just pulls from a whole bunch of different chapters. So we call this chapter 11, although we'll bring in a whole bunch of stuff. This is day 1. You're going to have 3 whole days of notes. Today we're going to really focus on what is a radical, and what does it mean to simplify that radical? And these are 2 things that you probably know what they are, but we're going to bring them together. So our essential question is simply, can I simplify square roots? And you should see a pattern here. If we're simplifying radicals and simplifying square roots, guess what a radical is? A radical is a square root. So let's look at the different pieces. So this right here, that is a radical sign, or some people call it a symbol. And then a word that's probably new that I will be using a lot is the number that's actually under the square root. That is called a radicand. Like canned, not can't. A lot of people say can't with a T there, but it's a radicand. So when I say, hey, the radicand's 8, you need to know that I'm talking about that number right there. Now, let's talk about some square roots that you should be familiar with. For example, if I say, simplify the square root of 4, you should be able to say, oh, well, I know that the square root of 4 is 2. Or if I say, simplify the square root of 100, you need to be, and hopefully can say, that that is 10. And we need to have these memorized. If you don't, we're going to write out a whole bunch of numbers over here. And these numbers, when I take a square root of 4 and get a whole number, that is called a perfect square. So a perfect square, and I normally write these at the top of like any sort of paper, or I would write this on the whiteboard, or if you've seen these perfect square, they're actually around my clock. So you've seen these numbers before, and this is how you get these numbers. So perfect squares, write these out with me. 1 times 1 is 1. We're not going to use that a whole lot, but that is a perfect square. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. That was a weird thing to say. Sorry, hard thing to say. 100, 121, 144. And there are more, but we're going to stop there because we really only ever need to go to 12. So those are perfect squares, and we're going to be looking for perfect squares, and I'll tell you what that means soon. But we're going to be looking for perfect squares within other numbers. So before I go any farther, I'm going to just have us reflect back here, and then there will be a second video with examples where I might give you the square root of 8. And the perfect square, a square root of 8 isn't a whole number, so we got to figure out how to do that.